Okay, so now that we've looked at methods for solving quadratic equations, right? There's four methods for solving a quadratic. They are factoring, completing the square root property, which is kind of its own thing. You know, I wouldn't think of using the square root property unless I'm all set up to take the square root of both sides. And then there's the quadratic, the completing the square method. And then there's the quadratic formula. Now we prefer not to complete the square because the quadratic formula comes directly from completing the square. Okay, so in order, I want to think factoring first. Factoring by far and away is going to be the easiest, most efficient method. And then if the equation doesn't factor, or if I'm just not seeing the factors, then the next thing is to use the quadratic formula. Okay? So let's try problem 23 here. It says that a ball is thrown upward from the top of a building that's 96 feet tall with an initial velocity of 80 feet per second. The distance, s, in feet, from the ball to the ground after t seconds is given by the equation s equals 96 plus 80t minus 16t squared. Okay, after how many seconds does the ball strike the ground? So s is the height, t is the time. Okay, well, the ball would be on the ground if the height is 0. So I'd want to set s equal to 0 in this equation and solve the equation 0 equals 96 plus 80t minus 16t squared. Let me get everything onto the left. That way the leading term there is positive, a. I can make the numbers a bit nicer here by dividing both sides by 16. Like 16 goes into all three of these numbers evenly. Okay, so let's go ahead and do that. 16t squared over 16 is t squared, minus 80t divided by 16 is minus 5t, minus 96 divided by 16, so 96 is the same thing as 16 times 6. So minus 6, that's all equal to 0. And by the way, look for those situations where you can make the numbers nicer than what they are. Okay? It's going to be a lot easier for me to factor this guy right here rather than this guy up here. Okay? So now I'm ready to factor this. Be t and t. The factors of 6 that I want to use are 6 and 1. And that's going to be a minus 6 and a plus 1 to have the signs work out. So let me go ahead and check this. Got t times t is t squared. T minus 6t is minus 5t. And then negative 6 times 1 is negative 6 at the end. Okay, that looks good. So then set each factor equal to 0. You got t equals 6 or t equals negative 1. T is the time. The time can't be a negative. That doesn't make any sense for what we have. Okay, so it looks like it's going to be 6 seconds for the ball to strike the ground after it's been thrown up in the air. Okay. Problem 24 says that a slingshot is used to propel a stone upward so that its height h in feet after t seconds is given by the equation h equals 95 plus 88t minus 16t squared. At what time or times was the rock or the stone 175 feet high? Okay, so h is the height and t is the time. Well, I'd want to set the height equal to 175 and then solve this equation here for t. So if I get everything on the one side there, if I subtract 175 from both sides, actually let me get everything onto the right, onto the left, excuse me. I'm going to add 16t squared, subtract 88t, and then subtract 95. 175 minus 95 is 80. and that's all equal to 0. Okay, and now I can make the numbers a bit nicer than what they are by, let's see, 16 goes into 80, but 16 does not go into 88 evenly. Okay, 8 would be the biggest number that divides all three of these numbers. Okay, 8 times 2 is 16, 8 times 11 is 88, and 8 times 10 is 80. Okay, so I'm looking at 2t squared minus 11t plus 10 equals 0. Again, look for those situations where you can make the numbers nicer than what they are. Okay, like the problem becomes way more difficult, you know, with these bigger numbers. Okay, so now the next thing is if we try to factor this, the factors of 2 are 1 and 2. The factors of 10 are 1 and 10. That's not going to work. Or 5 and 2. That's also not going to work. Okay? And if we don't see the factors right away, then the next thing is to use the quadratic formula. Okay, so I'm using the quadratic formula here. And let's see, so the opposite of b, that's 11, plus or minus the square root of b squared, negative 11 squared is 121, minus 4 times a is 2, times c is 10, and this is all over 2a, 2 times 4, or 2 times 2 is 4 in the denominator. Okay, so then from that I got 11, plus or minus the square root of, let's see, 21 minus 4 times 2 is 8, times 10 is 80. So 121 minus 80, that'd be 41. And this is all over 4. So now this would be as simplified as I can get things. But now I'd want to go to the calculator next and type this in. Okay, so let's do that. If we take 11 plus the square root of 41 and then divide that by 4, we get 4.35. That's going to be one answer there. Okay, and then take 11 minus root 41 divided by 4, and you get 1.5 if you go nearest 2 digits on that. Okay, t is the time, and the time is in seconds. Okay, so it looks like after 1.15 seconds, the rock is going to be at 175 feet in the air, and then it's going to continue to go upward. It'll reach a peak and then fall back to Earth, and after 4.35 seconds have gone by, it'll be at the 175-foot marker again, and that's on the way down. Okay, so both these numbers are going to be solutions. Okay, and but by the way, so whenever you have a story problem like what we have here, okay, always include the units. Okay, because you know, are you talking about 1.15 minutes or 1.15 hours, or no? We're you know, that'd be something else, right? So there's 1.15 seconds and 2.35 seconds. Okay. All right, so, you know, I guess the way that we did this problem by using the quadratic formula here, that was actually our best option. Like, so this equation wouldn't factor nicely, right? Like unless you're thinking of these numbers, okay, these are not natural numbers that I'd be using. So when I'm trying to factor, you know, I'm using, you know, integer values, you know, like we did up here. Okay, so this right here, this method that we use, that's actually the best method that you could use for this problem, okay, using the quadratic formula. Let's try problem 25. So it says the length of a basketball court is 6 feet less than 2 times the width. If the total area is 4,700 square feet, find the dimensions of the court. Okay, so we got this basketball court. Here's the length, and here's the width. Now, I don't know the length. I also don't know the width, but they're telling me the length in terms of the width. Okay, so it says the length of a basketball court is 6 feet less than 2 times the width. So whatever the width is, if I take 2 times that, and then take 6 feet less than that, so 2w minus 6, then that'd be the length. Okay, we have a rectangle, and the area of any rectangle is always length times width. Now the area of this rectangle, the area of this basketball court, is 4,700 square feet. Okay, that's equal to length times width. The length again is 2w minus 6. So then times w equals 4,700. And let's see, if I distribute w, I got 2w squared minus 6w. And if we subtract 4,700 from both sides, then 2w squared minus 6w minus 4,700 equals 0. Okay, and that would be the quadratic equation that I got here. By the way, all of these examples, all of them are going to be where you're going to have a quadratic equation that you're solving. Okay, so like if you come up with a formula and that does not involve a quadratic, so it's not something of the form ax squared plus bx plus c equals 0, is probably going to be a wrong answer. Okay, so that, you know, just keep that in mind. So we want to come up with a quadratic. Let's see, all 3 of these numbers are even numbers, right? So I can divide by 2 on both sides. I'll have w squared, half of 6 is 3, so minus 3w minus half of 4,700, that'd be 2,350. That's all equal to 0. Okay, so this guy here would be the equation to solve next. Okay, now this will factor. So if I take 50 times 47, okay, 50 times 47 is, 50 times 47 is 2,350, okay? And so if we have a minus and a plus there, w times w is w squared. 47w minus 50w is minus 3w. And then minus 50 times 47 is 2,350. Okay, now not everyone's going to see this, you know, how it's factors. So again, well, like, what do you do if you don't see this? Well, I'm using the quadratic formula, right? So there's always a way out, right? So some people, like when they get to this point, would factor it, like, you know, it does factor. But if we don't see the factors, then we're using the quadratic formula. Now the answer is still going to be the same thing, you know. Just keep in mind that if you're using the quadratic formula, like you're going to be taking a little bit longer with getting the answers. Okay, so like I wouldn't want to use the quadratic formula every single time. Okay, factoring always is going to be the best option to think of first. And if you can't see the factors, you know, pretty much right away, then the next thing is to use the quadratic formula. Okay, so anyway, this did factor nicely. Here's the factors there. W minus 50 equals 0 means that W is 50. W plus 47 equals 0 means that W is negative 47. W is the width of the court. That can't be a negative. That doesn't make any sense for what we have there. Okay, so I would throw away the negative 47. That doesn't make sense for this problem. So the width of the court is going to be 50 feet. And the length of the court would be, W is 50, so 2 times 50 is 100, minus 6 is 94 feet. Okay. All right, we'll go ahead and stop the video right here, and I'll pick up with problem 26 in the next one there.